think about some of the big challenges in the 21st century, obviously climate change is one of the top ones. In fact, President Obama has declared that it's one of the most important threats to society. It has been recognized by the United Nations as a very important problem that requires worldwide attention. And the issue is, what do? If you want to know what to do, if you want to know where to build the clean energy solutions, where to put up the wind farms, where's the right place to invest in solar energy, that all depends on the climate. And importantly, it depends on the variability and the change that we expect. Our job is to try to understand how climate changes, where it will change, by how much, and what its impacts will be on human societies as well as on ecosystems. My name is Jim Kinter. I'm the director of the Center for Ocean, Land, Atmosphere Study. I'm also an associate professor of climate dynamics here at George Mason University. We like to say that we're solving 19th century physics with 21st century technology. We use supercomputers to solve the equations that govern the Earth's atmosphere, the global ocean, the land surface. And we do that in a fully coupled mode. We let the simulated atmosphere, the simulated ocean, the simulated land surface all interact with each other inside the computer. So it's really very exciting to watch these simulations. We're able to simulate spontaneous formation of tropical cyclones, such as you see in the image, and also all of the characteristics of the climate system that are important for human systems and for ecosystems. We've observed climate variability for a very long time, and we have seen what it can do. You can look at the heat wave that was in Russia this past summer. You can look at the flooding in Pakistan. You can look at any sequence of tropical cyclones that have come across the Caribbean or hit the eastern part of the United States or ravaged Japan or Southeast Asia. When you look at all of those aspects of the climate system, you can immediately see the impact it has on the economy, not just the U.S. economy, but the worldwide economy. What we would like to be able to do is, first of all, improve our understanding of that climate variability, and then secondly, actually use that understanding to predict how climate varies. Beyond climate variability, we'd also like to be able to understand how climate change is going to influence those predictions. What will climate change mean to the man in the street or to the decision maker who has to make hard decisions about investing in infrastructure or technology? All of those things will have immediate and large impacts on the economy. It will be an opportunity for jobs in the alternative energy world, in the infrastructure world, and also one of the things that I didn't mention earlier was our educational aspect. I think this is a very important point that sometimes is missed. The people have to be able to tell the difference between hype and real information. And so what we're also doing, in addition to educating the graduate students and hiring young professional scientists, is we're also producing information that's more digestible to the less technically inclined part of the society. And we're trying to educate here at George Mason the undergraduates about how to separate real information from what I'll call politically driven information.